In this video, we're going to learn the power rule for differentiation. Before I get into the power rule, I want to remind you how we've been finding the derivative, and that's with the limit definition of the derivative. And so if you recall, the limit definition says the limit as h approaches 0 of f of x plus h minus f of x all over h. And so let's do a quick example to remember how to do this. If I had f of x equals x squared, f prime of x is going to equal the limit as h approaches 0 of f of x plus h. And remember how we do that? We take x plus h and plug it in wherever there's an x. So we have x plus h quantity squared minus f of x. So that's going to be minus x squared all over h. And when I simplify that, we multiply it out. We get x squared plus 2xh plus h squared minus 8x squared all over h. Now we can combine like terms. The x squareds cancel each other out. So we get limit as h approaches 0 of 2xh plus h squared over h. I could try to plug the h in now, but that would give me 0 over 0, and that's indeterminate. So let's go ahead and factor an h out of each of the top two terms. So I get h times 2x plus h all over h, and then those h's cancel. So now I take the limit as h approaches 0, and that means we're going to end up with the answer 2x. So given f of x equals x squared, f prime of x equals 2x. Now let's look at the power rule. The power rule says if f of x equals x to the n, then f prime of x is equal to n times x to the n minus 1. All right, and another way to say that is if you are taking the derivative. This is just a different notation. The derivative of x to the n is equal to n x to the n minus 1. Again, I'm just showing you a couple of different notations. F prime of x is the derivative of f of x. Alternately, we could say if I wanted to take derivative d over dx of x to the n, it's equal to x to the n minus 1. Same thing, different notation. So let's go ahead and look at how this plays out. If we were to look at that example that we just did, if f of x is equal to x squared, then f prime of x is equal to, remember we take the n and we bring it up front. So we bring the 2 down front, and now we bring that 2 right down front, and then x, and then we say to the 2 minus 1 power. So that's 2x to the first power. And notice that that's the same answer that you got when you did it with the limit definition. All right, let's do one more problem. What if I have f of x equals x to the first power? All right, then what would f prime of x equal? F prime of x would equal, well, we bring the 1 down front, so we have 1x, and then to the 1 minus 1 power. So that equals 1x to the 0 power, or it equals 1. Because x to the 0 is just 1, isn't it? All right, so let's see if that makes sense. If we have a function f of x is equal to x, that is just the line y equals x, right? That goes through the origin. What is the slope of that line? If you have the line y equals x, the slope of that line is just 1, right? And it's 1 all the way along that line. So at any point, the rate of change of that function at any point along that line is going to be 1, isn't it? So it makes sense that the derivative is always going to be 1. Now the power rule tells us that if f of x is equal to x to the n, that f prime of x equals n times x to the n minus 1. And it specified that n was an integer, but actually the power rule works for all non-zero exponents, all right? So if you had a fractional exponent or a negative exponent, you could use this power rule as well. So if I had, if f of x is equal to x to the 1/2 power, and I wanted to take the derivative, then f prime of x, we do the same exact thing. We bring the 1/2 down front, and then we take 1/2 minus 1, and so that gives us 1/2 times x to the negative 1/2, doesn't it? All right, and we could rewrite that as 1 over 2 times x to the 1/2. And that may take some review of your pre-calculus to remember how to deal with the negative exponents. Likewise, if I had f of x equal to 1 over x to the 4th, then I could rewrite that. Then f of x is the same as x to the negative 4th, isn't it? And f prime of x then would equal, you bring the negative 4 down, and then we take negative 4 minus 1, and so you get negative 4x to the negative 5th, which we could write as negative 4 over x to the 5th power.